Okay, now that we are a little bit more familiar with probability, we're going to look at another way of organizing data, and that is tree diagram. This is a little bit tricky. Actually, drawing it out is not very tricky, but actually using it sometimes could be tricky. So let's look at this first. Two identical cookie jars are on a counter. Jar A contains chocolate chip and 2 peanut butter cookies, while jar B contains 1 chocolate chip cookie. We select a cookie at random. What is the probability that it is a chocolate chip cookie? All right, let's go ahead and just draw a tree diagram to represent all that information. So you start from here. This is you. You're going to first pick a jar. So the first stage is picking a jar. After we draw my tree diagram very symmetrical so that it's a little bit easier to All right. So at the very beginning, they tell me that the two cookie jars are identical. So this part is kind of critical. So then what the reason they're telling you it's identical is that you don't have a preference to pick one over the other because they look exactly the same. So then if you were to pick one, you wouldn't really want to pick something more than the other one. You wouldn't want to pick jar A more than jar B, because if that happens, then your probability of choosing A is higher. Since they're identical, there is no preference. All right, now it's going to be a little bit different. Once you pick a jar, let's say you pick jar A. Jar A has 2 chocolate chip and 2 peanut butter. So what's the chance that you get a chocolate chip? Well, since it's just 2 and 2, this is going to be 50-50. Okay. Now let's look at jar B. If you happen to pick jar B, it only has 1 chocolate chip cookie. So what's the chance of you picking a chocolate chip cookie? Has to be 100%. You have no other cookies to choose from, and there's no way you can actually get peanut butter because it doesn't exist. So the question is, what is the probability that you pick a chocolate chip cookie? Well, what are all the possible ways to get a chocolate chip cookie? Now, you cannot just say there are 5 cookies total. There are 3 chocolate chip, so then you just say 3 out of 5. No, that is not true, because this represents if you put all 5 cookies together in a jar and then you just pick one. But that's not true. What happens in this question is that you have to first go through the hurdle of picking a jar and then you pick a cookie. So then the probability is going to be different. Then you only have 1 jar and 5 cookies inside. Okay, so this is a little bit tricky. So multiplication principle of probability says you have to figure out the probability at each stage and then you multiply them together. So at the first level, you pick a jar, that's 50-50. And then you pick a cookie from that jar, and it depends on what's available in that jar, and you have different kinds of possibility. So what you do is, let's say that you picked jar A, and then you happen to pick chocolate chip cookie. What is the chance that that could happen? It's just going to be 50% times 50%, because it's the probability of the jar times probability of the cookie in there. So 50% times 50% is 25%. Okay, so this is 50% times 50%. Okay, let's try another one. What's the chance that you pick jar A and then a peanut butter? Same thing actually. This one is going to be 50% times 50%, another 25%. Okay, what's the chance that you pick jar B and get chocolate chip? 50% times 100%, which is 50%. And last part, what's the chance that you pick jar B and get a peanut butter? That is impossible, so 0%. All right, now notice this is all the probabilities in your sample space. So then if you add all this up, you have to get 100%. Okay, you have to get 100%. Okay, so now let's go ahead and look at the question again. What is the probability that it is a chocolate chip? Well, look at all the probability that you actually get chocolate chip. 25% and 50%. So that is 25% plus 50%. So there is actually 75% chance that you will get a chocolate chip. All right, let's have you try one. Okay, so let's look at this question first. If it rains tomorrow, the probability is 0.8 that John will practice his piano lesson. If it does not rain tomorrow, there is only a 0.4% chance that John will practice. Suppose that the chance of rain tomorrow is 60%. What is the probability that John will practice his piano lesson? Okay, I'm going to set up the tree diagram for you, but you have to figure out all the probabilities. So let's think about this process in order. What's the first thing that decides whether John practiced piano or not? Whether it rains or not. So the first stage is rain or no rain. Once that happens, the weather decides whether it rains or not, John will decide whether he practiced or not. Okay, so then practice, no practice. Same thing here, practice, no practice. All right, so now what you're going to do is fill out the rest of the probabilities and then figure out what is the probability that John is going to practice his piano lesson. So pause the video, fill out all the probabilities, and then come back and check your answers. Let's look at here. The chance of raining tomorrow is 60%. So 60% already goes here, and no rain is going to be 40. On these questions, please don't think too much. Like, you don't want to say, oh, well, there's 60% chance of raining, but it could also hail, or it could also snow, or the snow could turn into rain later. Don't go crazy like that. This is not what it's asking for. We are just trying to practice with very, very simple and easy, or just kind of not crazy problems. Real life applications can come later, but right now let's just practice how to actually solve these with correct methods. All right, so 60% chance raining, 40% chance not rain. And then, let's see. It says if it rains tomorrow, the probability is 0.8 that John will practice his piano lesson. So that is 0.8 or 80% chance if it rains, and then he has 80% chance he's going to practice. So there's 20% chance that he's not going to practice. If it does not rain, there's only 0.4 chance that John will practice. So that is 40% here and 60% here. So then what is the probability that John is going to practice? So then look at all the possibilities where he is going to practice and multiply the probabilities together. So this is 48%, 16%. Let's fill out the rest just so you can double check. And then what we're going to do is just add the 48% plus 16%. And that's going to give us 64%. So there's 64% chance that tomorrow he is going to practice. All right, now we're going to apply the same thing to conditional probability. Conditional probability is a little bit tricky because it really depends on how you read the question, or if you read the question exactly the way they want you to read it. Conditional obviously means that it depends on condition. So it's going to depend on another outcome. So the probability of A happening given that B happen, given B happening is written as, so if you want A to happen and then given B, it's going to be probability of A given B. So this part is the given. Okay, the one you write later is the given. The way we read it is probability of A given B. I'm gonna, and then probability of A given B, so the actual formula is probability of A and B over probability of B, so over the given. So let's look at the question again, that chocolate chip question. Okay, you have two identical cookie jars on the counter. Jar A contains 2 chocolate chip cookies and 2 peanut butter cookies, while jar B contains 1 chocolate chip cookie. We select a cookie at random. Given that it is a chocolate chip, what is the probability that it came from jar A? So this question is a little bit different because it says that given it is a chocolate chip, so you know this thing was a chocolate chip. What's the probability that it was actually from jar A? Okay, what's the given? The given is that it's a chocolate chip cookie. So what we want to do is write this formula. So it's the probability of jar A given that it is a chocolate chip. Okay, so applying the formula, probability of jar A and chocolate chip divided by probability of chocolate chip. Probability of jar A and chocolate chip, so you have to look at the tree diagram from yesterday. Probability that it is a jar A and chocolate chip is 25%. Divided by probability that it is just a chocolate chip cookie, which we said yesterday was 75%. So this turns out to be 1/3, which is about 33%. All right, conditionals are a little bit hard because you do have to try to figure out what is the given, which means, you know, the condition. You had to kind of adjust your reading to how they want you to read the question. Let's try this next one. There are 2 pre-calculus sections at West High School. Mr. Abel's class has 12 girls and 8 boys, while Mr. Bonnet's class has 10 girls and 15 boys. If a West High School pre-calculus student chosen at random happens to be a girl, what is the probability that she is from Mr. Abel's class? So you got to ask yourself, what is the given? Is the given a girl, or is the given from Mr. Abel's class? Please don't think too hard. A lot of these questions are pretty much the same kind of language, so you want to just adjust yourself to the language. If the student chosen happens to be a girl, that means that is the girl, the given, the girl. So then what you want to do is figure out the probability that this person is from Mr. Abel's class, given that this is a girl. This, you know, the condition, the person is a girl. What's the chance that this girl is actually from Mr. Abel's class? All right, you might want to draw out your tree diagram and then figure out this conditional probability. So pause the video, go ahead and do it, and then come back and check your answer. Okay, so please take a look at the tree diagram. So I changed the 12 girls and 8 boys, those kind of information into percentages so that it's easier to calculate. And so at the very end, you want to apply the formula, probability of A and girl, so probability of Mr. A's class and a girl, divided by probability of just getting selecting a girl. Okay, so please check your answers. The last part is binomial distribution. So there are some things in life where there are only 2 outcomes. It's either this or that. For example, when you toss a coin, it's either heads or tails. You shoot a basket is either in or miss. Your cell phone is either iPhone or not iPhone. Okay. So when that kind of thing happens, we call this a binomial. So binomial, or kind of think of bi means two kinds of things. So this is where we have either success or failure. So let's say that success, we call this P, and then Q is failure. Then Q must be 1 minus P, because you either succeed or you fail, and then that has to add up to 100%. So then kind of going back to binomial theorem, which we did in 9.2, we can use binomial theorem to figure out the probability. Now remember that P plus Q has to be equal to 100%, and then N is going to be, some kind of how many times do we let this trial, how many happen. So like how many trials do we have? Now going back to binomial theorem, we know that this is going to be n choose 0 of p to the n q to the 0 plus n choose 1 of p to the n minus 1 q to the 1, and then so on until the last one is n choose n of p to the 0 q to the n. Okay, and n means number of trials. So how many times do you try it? All right, so let's look at a question where we can actually use this. Suppose that Michael makes 90% of his free throws. That's really good. If he shoots 20 free throws and if his chance of making each one is independent of the other shots, meaning he's not throwing one in and he says, oh my gosh, I didn't get it in, and now I'm not sure if I can get the next one in. Like, he's still getting 90% out of his free throws every time. What is the probability that he makes? A, 20 successes. All right, let's think about P and Q first. P means make it in, Q means fail. So P is going to be 90%, and then Q is 10%. And P and Q obviously has to add up to 1. So what's the chance that you get 20 shots in? That means N is going to be 20. Okay, so what's the chance that he gets it in? Well, he's going to get it in 20 times, and then he's going to miss none because he's actually shooting 20, right? So he's going to make all 20, but he's going to miss none. Okay, this is the probability. But the question is, how many ways can these 20 shots come out of 20, which is going to be 20 choose 20 or 20 choose 0. It doesn't really matter because we're going to end up with the same number. So now plug in the numbers, 0.9 to the 20th power times 0.1 to the 0 power times 20 choose 20 or 20 choose 0. This gives us a answer of 0.122, or about 12.2% chance that he is going to make all 20 of his free throw. Okay, so let's try another one, and hopefully it will make a little bit more sense. Probability of getting 18 successes out of 20 free throws. So success is 18, which means success, that is P, is to the 18th power, meaning, you're going to make 18 successes in 20 shots. And what is the leftover, or what if you don't make it in? So I guess what's the opposite of success is the failure. So that means Q. If you don't make it in, if you make it in, it's P. If you don't make it in, it's Q. And then so out of 20 shots, if you're going to make in 18, then 2 of them, you're not going to make it. Now, this is probability. Again, this is probability. But no one says that you have to make 18 shots in a row. The 18 shots could come out any form of the 20 shots. It could be 18 at the beginning, 18 at the end, or somehow dispersed throughout the 20 shots. Therefore, we need to also multiply by how many ways 18 can come out of 20, which means 20 choose 18, or you can do 20 choose 2. It will give you the same number. Okay, so let's look at the probability of making it in, which is 0.9 to the 18th power. And then there's 10% chance that he's not going to make it, so that's 0.1 to the second power. And then times how many ways can you rearrange 18 shots, 18 successes out of 20. And then just use the calculator to calculate this. So 0.9 to the 18th times 0.1 to the second times 20 choose 18. That is about 0.285, or change that into percent, 28.5%. All right, the last one. At least 18 successes. So at least means 18, 19, or 20. So basically what you want to do is find the probability of 18 plus the probability of 19 plus the probability of 20. Okay, so this is how it's going to look like. Probability of 18, which means 18 successes, which means 2 failures, and then times 20 C18 plus probability of getting 19 shots in, which means you miss 1, and then 20 choose 19 plus probability of getting 20 shots, which means you miss none, and then 20 choose 20, and then whatever that is. Okay, this is 0.677, or about 67.7%. Okay, the last one. Okay, so this one you're going to practice 10 dimes are tossed, find the probability of each event. Okay, so heads on all 10 times. So you have to think to yourself, what is considered success? What is considered failure? Success is what you want. It doesn't really mean that you're succeeding. It just means this is what you want. So in this case, you want heads. So what is the probability of getting heads? What is the probability of getting tails, which is considered failure in this case because it's not what you want? And n is going to be 10 because you're tossing it 10 times. Okay, so think to yourself, what is P going to be? What is Q going to be? And how would I set up this question so that I can solve probability? So pause this video, give it a try, and then come back and check it. All right, so heads means that what's the probability of getting heads on a coin? That is 50%. So the other 50% is getting tails, which in this case would consider failure. So if you want heads all 10 times, that means P is to the 10th power. That means Q is to the 0 power because you're tossing 10 dimes and you want heads all 10 times. That means no room for tails. And remember, you need to also multiply by 10 choose 10 or 10 choose 0, either way. The answer is going to be, oh, that's a very small number, 0.000977. Okay, all right, next. Exactly 3 heads. So you might also want to give this a try, pause this video, and then come back and check it. All right. So exactly 3 heads means P is to the 3rd power. Q is going to be to the 7th power because if you want 3 heads, that means there are 7 tails. And then multiply by how many ways can 3 heads come out of 10, and then calculate. This one is kind of easy, I guess, in the way you calculate because P and Q are both 50%. So you would actually just do 0.5 to the 10 because they add up to 10. And calculate. Let me multiply this together. Okay, so it is 0.117. That is the answer.